A spherically symmetric gravitational system of particles has a mass density rho is equal to rho naught for radius less than equal to r and 0 for r greater than r. So basically it is suggesting something like this, that there is a sphere which is having a density rho naught, and it is having a radius of capital R. Where rho naught is a constant, a test mass can undergo circular motion under the influence of gravitational field of the particles. Its speed v as function of distance r from the center of the system is represented by. So now for this kind of a problem, over here I wish to tell you something which you may not know. So we are finding electric field inside the sphere and outside the sphere. So you can do it using several ways. So for the time being I am teaching you Gauss law for gravitation. So we will be using it using Gauss law for gravitation. So how do we write the equation for Gauss law for gravitation? So the first thing which I am writing is that the electrostatic force between the two charges is written like this: 4 pi epsilon naught q1 q2 by r square, and the gravitational force is written as g m1 m2 by r square. So I am saying that these two equations are identical. I'm not saying that these two forces will come out equal or anything like that. I'm just saying that these two equations are identical. So I can say that the charge here is identical with mass on the other side. The distance here is identical with distance on the other side. And 1 by 4 pi epsilon naught here is equivalent to g on the other side. So when we use the expression for Gauss law for electrostatics, so we write it as cyclic integral of E dot A is equal to Q enclosed by epsilon naught. So for the Gauss law for gravitation, I can write it as E dot A. So I can replace Q enclosed with mass enclosed and 1 by epsilon naught with 4 pi g. So I am replacing this with 4 pi g and Q with mass enclosed. So we get an expression for Gauss law for gravitation. So if I use this expression for Gauss law for gravitation to find the value of electrostatic field inside this sphere, so I am selecting a Gaussian surface over here at a distance small r from the center. So at a distance small r from the center, if I use rho naught, so I can write it as mass enclosed upon 4 by 3 pi r cube, and we obtain that mass enclosed equals 4 by 3 pi rho r cube. And if we use the expression for E dot A, so we can write it as E dot 4 pi r square is equal to 4 pi g, and mass enclosed will be written as 4 by 3 pi rho r cube. Rho r cube. So if we are using this term, so we can chop it out 4 pi, and r square can be removed. So we get E as equal to 4 pi rho g by 3r. So E is proportional to r. So now if we wish to write an expression in this way, that the force of gravity, that is if I write the force of gravity is balancing the centripetal force, so I can write it as me, that is 4 pi rho g r upon 3 is equal to m v square upon r. So we get an equation like this. So m and m can be cancelled out, and we get v square is equal to 4 pi rho g r square by 3. So I can say that v is proportional to r. So from here we can say that v is proportional to r for any point inside the sphere. Now outside the value is going to be E is equal to gm by r square. So outside the value is going to be gm by r square. And this time if we write the force equation, so we can write it as me, that is m g capital M by r square is equal to small m v square by r. So from here we obtain that v is proportional to 1 by root r. So we are getting an expression like this, outside for outside the sphere, and an expression like this for inside the sphere. So now if we look at the graphical representation, so inside it is going to be directly proportional to r, that is it should be a straight line. So option A is having directly proportional and this is having directly proportional, the rest of the two are wrong. And outside it is inversely proportional to root r, so the graph must come down, it should not become constant. So we say that option C is correct for this particular problem. So inside it is directly proportional to r and outside it is inversely proportional to root r. So for v and r we are drawing a graph like this.